And we are live and
Okay.
hoping people have started joining.
All
Hello,
right.
guys. Hi, everyone.
Hello, hello. How's everyone
Hello.
doing?
How's everyone doing? Yeah.
Yeah, busy, busy. As always. Happy Thursday.
Happy Thursday. Weekends are near and people must be wrapping up their things for the weekend.
Yeah. Uh, it
Yeah.
is it's been a good week. It's been productive and yeah, I hope you're doing well. I hope everyone out there in the Metis community is doing well. I'm looking forward to chatting today.
Yep. Mattis community devs must be busy with the hackathon that's going on. I'd like to mention, so before we start, I'd like to mention about the hackathon and then I will hand over to you.
You bet. Sounds good.
So, yep. So, hello everyone. Welcome to the live stream, another series of the workshop that we are doing every week. And there's some issues. We were not able to be live last week, but here we are back again and happy to be with you, the dev communities, the new developers, or the community that always engage with us. Um, this is the second part of the graph workshop, and we had one last we are going to see about the powerful subgraph techniques with the graph and using Metis Andromeda network today. And before I hand over to Marcus, first I welcome Marcus for joining us to give us more information and more detailed techniques about the subgraph. And this is going to be interesting for sure that I know. So before I hand over to Marcus, I would like to mention about the most interesting thing going on the Mice community. So I want to take a few minutes to talk about something that is happening right now and that a lot you might want to get involved in as well, especially if you are building, experimenting with AI, or just exploring what's possible at the age of Web3. So, Hyperion. We have launched the Hyperion testnet, and we are having Hackathon, which is a global hackathon hosted by Metis, built around the Hyperion testnet. So, which is basically our next generation layer to build specifically for AI native applications. Interesting, right? So now. This is not just the another hackathon. So hyperhack is about giving developers the space, tools, and support to build real-time intelligent applications, things that don't just run on a blockchain but think, respond in a real time, right? So we are talking about dApps powered by autonomous agents, on-chain AI workflows, and event-driven smart contracts. And it's not backed by a real ecosystem that's shipping, right? So this is all about hackathon, and I would like all of you to participate in it because there is a prize and there is a 200K USD in total prize, and which is split across 3 tracks. So an additional 30K is bonus rewards just for teams who integrate Elite, right? And that's on the top of the mentorship, early mainnet access, and ecosystem spotlights, and even NFTs for early participants, right? So these are the 3 main tracks. So track one is like AI native and a core aligned projects. So this is apps that think like dApps with AI embedded in the core logic, on-chain inference engines, projects that use Hyperion's built-in AI co-agent, right? Proposal views, decentralized knowledge agent that answers community questions, right? And track two is real-time system. So for as example, a fast-paced multiplayer blockchain game with AI-powered NPCs, right? Real-time analytics dashboard for token activity. And the third part is infrastructure and tooling. So dev console for deploying and testing the agents. Um, so like this. So bonus track, most interesting part is here is the bonus track using elite integration and extra 30K. So now let me just give you the quick overview of the Elite. Elite is a framework for building and running AI agents on chain, and there are not AI wrappers. There is the difference between AI agent and AI wrappers, right? So these are autonomous actors that live in your smart contracts, and you define the agent's role, triggers, and behaviors, right? So that's how they work. So if you integrate this alith into any of these three tracks that I mentioned earlier, you are eligible for the bonus prize pool of 30K dollar, right? 30K USD. So whatever your main tracks earns, it's the addition into that. So how to apply and why this hackathon feel different and what you'll get out of it, your any more questions and a support, feel free to reach out us on X or on Telegram, Metis Dev community, and I will also attach a link meanwhile on the chat to get to know more about this hackathon. All right, enough from my side. And now, handing over to you, Marcus. We have Marcus as the developer relations from the Graph, and handing over to you, Marcus, now.
Okay, thank you. How are you doing today? And how is everyone in the audience today? I hope everyone's doing well. And today we're going to go over some subgraph techniques that will continue from the last time that we talked. We talked essentially about spinning up a subgraph and the fundamentals of that, understanding the little bitty pieces, and then understanding just high level. And we went over a lot of that, but we really didn't get into any techniques. And so the intent of this is to go through a few fundamental techniques as well that are important if anyone here is beginning subgraph development. I don't want to go crazy advanced. I don't want to go super simple. It's going to be kind of a breadcrumb along the way about some fundamental things that are best practices in terms of getting subgraphs extended and just being aware of these things as you're getting into this style of development. So does that sound good?
Yep, it sounds all good.
Cool. So I won't be able to see the chat as I'm like sharing
Right.
my screen
Yeah.
here. So like, and also if you have
Yeah.
any questions, Nidhi, or if the chat also has questions, feel free to interrupt me. We'll just go for, we'll go until the hour and then we'll sign off there. Does that sound good? And
All
also we'll
right.
leave
Yeah.
some time for questions
Yeah.
too.
Yeah.
Okay, cool. Okay.
Feel free to
So
drop your any questions, your feedback. Mostly the questions, right? We are going to check. To see about the techniques with the of the subgraph, and it's really interesting thing. So, feel free to drop your questions. You are in the comment section. It would be, to make it more engaging, and we have the Marcus. So let's get take the advantage of him and get to know more about the graph, right?
yes, that's the goal here.
Yeah,
So
that's the goal.
that is the goal. So let's go ahead and spin up a subgraph. We're gonna skip everything we did last time because we did it last time and just have a subgraph. We're going to deploy a subgraph and then we're going to talk through the subgraph and best practices as we extend it. Backing up, why are we doing this? Essentially, subgraphs are pieces of optimized code where if deployed well, they are very fast. If deployed without thought and consideration of optimization techniques, they can be very slow. And just because that's how, if you're handling the data poorly, if you're using techniques that are not optimized, if you're not understanding some caveats and trade-offs, it's all about speed. So this is about speed, and this presentation is going to be about making sure your subgraph maintains its high quality as you're building it out, and also sharing some powerful features along the way. So let's call this a Metis subgraph, and we already have that. And let's make I did that from last time. Mictor Metis demo. There we go. CD Metis demo. There we go. And let's go ahead and build out our subgraph right now. And we'll start at thegraph.com. And from here, should you want to build a subgraph, what we're going to go ahead and do is you can click on Start Building. There's a few different products available. A new one that I want to bring up is Token API. And essentially, it allows for easy token data and wallet data to be brought into your dApps. And so really take a look at that one. Real big fan of that one, how easy that is. You don't have to get super technical. It's just pretty much build it. And there's example repos in the Graph Protocol GitHub. So check out those example repos and get building with that. But other than that, let's go into subgraphs and we'll do Subgraph Studio. And that's where we build a subgraph. If you're in this hackathon and you want to build a subgraph, this is basically what you're going to have to be doing. Right now, Andromeda is the supported chain. I just sent a message to our chain integration team looking for an update about Hyperion. So maybe by the end of this, I'll have an update, but maybe not. Who knows? But hopefully we get to know about that. All right. So Metis subgraph demo. Okay. So we'll create a subgraph and it drops us right in. This is our dashboard. And we look for Andromeda. There we go. We have Metis. Oh, yeah, it's on the test nets on the bottom. They scroll them down here. Oh. Where is it? I saw it here a second ago. I literally deployed it a second ago. There's so many chains. Let me know if you see it at all, because I'm looking through. Monad. No. And we had it here a second ago. Andromeda, Metis. Why is it not here? I deployed a subgraph for Metis this morning. So this was here.
Yeah, take your time to find it.
Yeah.
Yeah.
It was literally just here this morning. No, it literally was just here. This is so funny.
Are you using different
Metis Andromeda, there it is. Yeah. Okay, cool. Okay. I was like, I'm not going crazy here. All right, cool. So if you haven't already installed the CLI, which we'll be using, it's yarn, npm, pnpm, or bun, global add, graph protocol, graph CLI. I've already done that. We're going to go ahead and grab this, drop this in the terminal. We're going to initiate our subgraph. So there it is. And then so you just type in the name of the chain you want. Here we're going to do Andromeda, Metis Andromeda. And we're going to be indexing a smart contract that's already deployed. And you could auto-populate this in. This is simply pulling it in from that initial string right there. And directory, it automatically populates, and then the contract address. I found this address this morning, and we're going to redeploy to this one. The reason I found this address, there's two things I look at smart contracts. Are they verified? And this one's verified. So that means we're able to actually interact with it with the ABI that we can see. And then also it has some events coming through this smart contract. So we're able to see what's going on. Backing up a little bit, subgraphs are very good at indexing events. So if you don't know anything about smart contract development, that's okay. Just make sure that there's events here. And this is essentially what we're going to be organizing in our subgraph. This is not very organized, and we're going to be organizing the data. So we have this smart contract here with 122 events. We'll copy the address, and we will bring it right in there. It's getting the ABI from Sourceify, the start block, and the contract name. If for some reason it's not able to grab the ABI or contract API, essentially the CLI is pinging Sourceify to get this information. Sometimes Sourceify has it, sometimes it doesn't. So if it doesn't have it, you're gonna have to manually go into the Explorer and grab that information, especially the ABI. So if the ABI is not brought in and Sourceify is not responding, sometimes it doesn't, you're gonna have to actually grab the ABI, copy this right here, save it as a JSON file on your local computer, and then point the terminal to that JSON file. So it did find that, so we don't have to worry about that. It also brought in the start block of where the smart contract was deployed. It gets the contract name from that API. And then here is where we're taking the contract's events and we're converting them into entities within our subgraphs database. So we say true. It's doing that thing right now where it's spinning it all up. Excuse me. Gonna have to have my coffee here. Are you a coffee drinker or a tea drinker? Nitty.
Coffee drinker, yeah.
Coffee? Okay. Yeah, this is
Yeah.
my second cup today, I think. So,
I see.
yeah. How many are you up to per day?
One just now.
Just one. Okay, there
Yeah,
we
in
go.
the
I get
morning.
it.
Yeah.
I get it. So these next steps, it'll say graph auth to authenticate your local computer. If you haven't authenticated before, you're going to do that. I won't do that right now because it actually displays the key in plain text right here, which I don't want to do on this live screen. So, and I've already also authenticated before, so I don't need to do that. What I'm going to do is cd into the actual folder, and then we're going to run graph code gen and graph deploy. CodeGen creates the type safety, and from there, did I CD it? Yep. Oh, hold on. Where is this? Hide. There we go. We're in the subgraph demo list. We're in right there, and sometimes we'll go to Studio. And we're already in graph CodeGen and graph build. That's what I was doing wrong. My brain is still waking up with coffee right now. It's like, what? Why isn't that working? So graph CodeGen is the type safety. And then, of course, then we have to build it. So then graph build and then graph deploy. So here we go. It's doing all the things. And we'll go ahead and deploy. So you can just copy paste right here as well if you ever feel like you're blocked. This is in Subgraph Studio once again, and it has a nice little step 1, step 2, step 3. So it goes right down there. And we'll deploy. So we'll use version 0.0.1, good semver, and then we are throwing it to the graph. Okay, so now we're going to see this is indexed, and already, bam, 123 entities already indexed, 99% done. It is flying. And we have our subgraph indexed. This is just the basic subgraph. There's no features beyond basic right now features, but already we could see these events stored as entities. So we have every single tokens claimed event. We look at the first 10 of those. We'll see the ID of the database entry as well as the amount in the account. We could see ownership transferred. We'll look at the first 5. Why not? And we can see this. So any singular, this is a little bit of GraphQL, by the way. GraphQL, it is, you notice a singular and a plural, claimable amount set and sets. Set will find the singular entity in the database. All you have to do is provide it with the ID of that exact entity. If you have plural, it will find multiple. And all the time I'm working with plural because I want more than one entity in the database. So you're typically always working with plural. And if you just click around, you'll be able to get this GraphQL to auto-populate and then send a query. And then here we have our data back. So yay. That was pretty quick. That was pretty easy. Any questions before I get into a little bit more of subgraph fundamentals and making sure it's a solid subgraph before you extend it?
Yeah, I don't see any question yet in the chat section, so I think we're good to go.
Awesome. Let's keep on going.
Yep.
So there are some fundamentals with subgraph development, like I said, that are really important to know. First things first, we want to optimize the speed of the indexing, and we optimize the speed of the queries that we send to it and get back. So we're really going to focus on those two things and making sure that we can build a great subgraph and some cool features along the way, like I said. So instead of just building them out right in front of you, we're going to go through the docs and really just do the docs, show the feature in real time, and just go back and forth just to show you the context of why they're important. So if we go to subgraphs and we look at best practices, I'm biased to these best practices. I wrote a lot of these.
Yeah.
So everyone I talk to wants really fast subgraphs. They want them. They want it to be as close to chain head as possible. And a really, really, another one they want is query speed and make sure their query returns get returned fast. So backing up right now, every single subgraph has a database inside of it. Now, Nidhi, have you ever worked with databases and ever done backend stuff?
Not like really.
Not a big one. Well,
Yeah.
I have been lucky enough to work with a lot of subgraphs, some of which have databases that are in the terabytes of size,
Uh,
and it's just a lot of data.
yeah, actually.
So to find a specific piece of data in that amount of data is can take a long time. And
Yeah.
so it is optimal for a subgraph to actually make sure that its database is the correct size for what it's being asked to do. If a subgraph has a database that's 10,000 times bigger than what it's needed, it's going to take much, much longer to find that data just by size, just by sheer size. So this feature right here, pruning with indexer hints, feel free to read through all of this in the docs, but essentially this is making sure your subgraph, let's go ahead and code, it's making sure your subgraph's database is a reasonable size. And there's a few different variables that you could pass to this to be accurate about the pruning of this database size. All of this is done here in subgraph.yaml, where, if you don't know, the subgraph manifest is the location where essentially we're giving the high level overview of what the subgraph is doing. So this is the subgraph.yaml. And here it is, indexer hints prune auto. This is simply pruning the subgraph automatically after a certain amount of time as determined by the indexer that's indexing this subgraph. So you're kind of saying, hey, I just want to build, and this is the amount of data that I need in the past. And not being super specific about it, you're just going to trust the indexer because you need it within a few weeks to maybe a few months. It's going to have it unless there's a major change in indexers, but you're just not super particular about it. Just doing auto, that's fine. There's a few other settings if you want to be specific about how many blocks back you want, because Metis is a fast chain. Let's say you want 10,000, 10 million blocks back. You can totally do that. And we could do prune number of blocks to retain. So instead of doing auto, let's say we'll do 10, 1, 2, 3, 1, 2, 3. We'll do 10 million. So that retains 10 million blocks from chain head at all times. Everything before that is cut, and everything with that you maintain and keep it with you. So this is a really important feature. I know this seems very simple, but a lot of people are not aware of this one. Please make sure you're aware of pruning. It makes your subgraph experience a lot better. Okay. Any questions on that, Medi?
Not yet.
No. Okay, cool. Not yet. Love it. All right. So simple enough. We went through indexer hints. This is another one that is really, really important. Improve indexing and query responsiveness by using derived from. Okay. So relationships, building relationships within entities. So this is another database thing. If anyone here is new with databases, that's okay. Essentially, if we want to go ahead and build a relationship between these pieces of information in our database, so what we can do is relatively simple. All we have to do, let's say we want to say, it's hard for me to code actually and do this at the same time. So this is nice. I'm going to create a relationship without derived from directive between ownership transferred and tokens claimed. Okay, so there we go. And that's not correct. That's interesting. That's funny. Let's do a different model here, and let's reject that and copy that, and we will go ahead and use this and a different model. Okay, so the relationship entity is essentially what we're doing here is building a relationship in these databases where if something should change in here, there we go. This is a very simple type of relationship, but it's not derived from. This type of relationship will actually say, hey, we have a tokens claimed here, and it's an array of tokens claimed. And this is going to be passing the data in here. We have the tokens claimed type and the entity right here. It's passing those in here. The problem is we're storing this data here, and this data here, and we're doubling it. All right. So if anyone doesn't know databases, now we're learning about it. This right here is a full copy of this right here. And if anyone knows anything about databases, once again, if we're copying database size and it's becoming bonkers, like we don't want that, it becomes, once again, slower for queries, slower for indexing. It's just slower all around. Dive from to this relationship. Okay, so now when we have derived from into this relationship, let's see how well this does. We are not copying this as one-to-one. We're not having a double. So there we go, derived from field ownership transfer. What we're doing is saying we have a tokens claimed right here, and we are getting all of this information, tokens claimed. This is the entirety of all of this. And we're just making sure that there is a backlink right here where we have ownership transferred. This goes right back up to this. And we are essentially keeping one copy of this data. And yep.
Yeah, sorry to cut you down. So, okay, I mean, this part looks like you are connecting two pieces of data together, right?
Correct. We're essentially saying,
that's what's going on here. So, like, my question is like, why would a developer want to set it up this way? Like, if you can give example, I guess.
Sure. Essentially, let's say we always see in entities, we're looking at transfers and users. And we have a user entity and we have a transfers entity. We don't want to double save every single transfer and a piece of data in the transfer entity as well as in the user entity. We don't want to have a transfer entity saved and then double it up in the user entity. We want to simply say, hey, here are all the transfers, and there's a relationship that goes to the user, and from there, we only have one copy of that data. That's what we're doing here. We're essentially saying we want to have just one copy of the data, and we are linking these two entities with this one derived from directive, and that really cleans up and keeps the database size small enough, which well, at least smaller, potentially half as big as this relationship would be if it was not using derived from.
Cool.
Was that cool?
Yeah.
Cool. All right. So let's keep on going. This is a really big one here. Now, this one here, shout out to David Luttercourt, who was the one who pushed this one. This is a huge, huge optimization, and it goes through a fundamental part of using databases. If you're not familiar with using databases, immutability. So, excuse me. Let's back up a little bit, computer science time. Mutability versus immutability. Mutability means you could change things. Excuse me. Immutable means you cannot change things. So if I want to make sure my database is going very fast, excuse me, and I know I'm not going to change the data on this entity, I'm going to want to keep, let's go to this one right here. I'm going to want to keep this immutable. Because let's just say I'm using this entity, tokens claimed. I'm personally using that as like a log of whatever's coming from the chain. I'm not planning to change it. I'm not planning to extend it. I'm not going to add, ownership, fake field, whatever, just whatever. I'm not going to change it at all anytime in the future. I leave this in here. And that essentially, as you're noticing, these are already populated with immutable true. It assumes that we're not going to change anything. If we are going to change something, let's say this, we already changed this. We're going to have to take away immutable true. We're going to have to completely take that away because guess what? We changed this. And from there, we're going to have to, keep on changing this. This is going to be one that we change all the time. Essentially, what this does is it stores this entity in a lower level piece of code type called bytes, and it's much lower level. It's much more performant for indexing. It stores it, and that's really, really nice. This is not stored as bytes. I'm trying to remember what it's stored as, but it's not as performant because essentially we're going to be doing possibly more changes here, and it's not as low of a level. It's a little bit higher of a level of
I have storage. A question here.
Yeah.
Sorry to cut you down in between.
No. This is good.
Yeah, thank you. So let's say if I'm building a subgraph,
Mhm.
how do I decide? I'm not sure if I'm asking this question too early, like if you are supposed to explain in the next minutes, but
Sure.
just dropping my question. So how do I decide that what should be marked as immutable and what should not? And
Yeah.
is
Great
it just
question.
about whether the data will change in the future or not? Like just to let the audience know, yeah?
Yeah, that's a great question. So I have a few strategies that I generally like to do for the most part. If I'm going to be having entities that are immutable, I like to keep them pretty much as logs as the events one to one. And
Mm,
then as I keep on building, I'll undo this right here because I'll just say these are simply root logs of things that are going on with the entities themselves. And then from there, I'm able to freely type
mm,
fake entity at entity, and then I don't make this one immutable. And from there, I know that this fake entity I'm going to be doing lots of transformations with. I could have good naming convention in the front of this. You know, I could say update fake entity. Basically, anytime I'm using an entity regularly, there's a lot of different things that I like to do in terms of more creativity. I like to keep the fundamental events immutable, just to have one-to-one copies of everything. And then from here, I can pass the data into here. I can do relationships. That's simply allows a lot of flexibility for me. And to see a really good example of this, I always like to go back to this one. Shout out to Jerry. I know Jerry is listening. I always go back to this one. The Jerry Okolo CryptoPunks subgraph. Does he have it in here? Yes, he does. Okay, cool. So if you want to see how relationships can be built and all of the different crazy features, just go through this and you can control A, like, grab it, copy it, drop it into chat GPT and just talk about it and learn about it. But this gives a good idea of entities, and you can see how this one does not have immutable because this one's very much customized. There's a lot of things he did, and that's fine. And so just be aware of that. There we go. We got it derived from right there. So we're already getting into it. A lot of customization happens whenever you are not making it immutable. Does that make sense?
yeah, I mean, yeah, that's the cool approach. Like keeping,
Here we go, right there.
yeah, event entities immutable like logs and using other entities for logic. So
Yep,
makes sense.
yep,
Yeah,
yep. He's simply passing in the event data into this, and it's going right in. And so he's never going to change that. That's what he's using, which is good.
cool.
And also, this is a really important one because assign implements the event entity. Essentially, this is never going to change. It's always the assign type of event, and it's always the event type of event. So this information, we're getting the amount from type log number. He's using this simply as a log from the chain. That's all he's doing. Okay. So let's keep on going. Is this helpful? I hope this is helpful
Yep.
for you and everyone. Okay, cool. And backing up, what type of performance increase can we see with this? Here's what's really cool. David Luttercourt, big shout out to him, did some good testing on this and found that if you are to use, he wrote this blog here on this, if you are to use the both bytes as IDs, which is, let me back up here. This is bytes as IDs. You're free to change it to whatever else you want. This entity in the database itself is a bytes type, and you could make this if you want to into a string or whatever you'd like, but that will be slower. And bytes is a very low level type for a piece of data. He showed that if you use both bytes as IDs, both here, and also he used immutable entities, there was a improvement in speeding, the speed of the indexing up to 28%, and the reduction of storage size by 48%, which is crazy. So huge amount of improvement for subgraphs. So just being aware of that. I like data. Hopefully everyone here is nerding out and likes data too. Maybe, I don't know. I have a guess that people here like data. All right, let's go back. Okay. So let's keep on going. There's a few more here, and then we'll build a little bit more. ETH calls. So once again, a little bit of computer science. If you're not using smart contracts, the ETH call, essentially, it's a call to the smart contract itself. And that smart contract makes a call, of course, to the node, the Metis node, or whatever node is out there to get the data. And then that has to come back to the subgraph. So essentially, we're relying on external infrastructure to get the data, as opposed to the subgraph going directly to the smart contract and back. It's going an extra step. And that extra step, of course, might take some time. And so that's the big story of what an ETH call is. And that's a really great best practice. If you're seeing a bind, do we have a bind in here? Is that part of the docs? Did I put this in here? Let's see. Yes. If you're in your smart contract, you are in your subgraph and you see a bind method right here, that means we are essentially attaching this event address, the actual smart contract, to this and the calls to it to this subgraph. And then we'll eventually be doing external calls to it. We have an external call. We have an instance get pool info. That's going to be one of those ETH calls right there. So we have that instance, and then we call that exact information, that ETH call, and then from there, that gets the data back. Now that takes some time. So ideally, we want to get rid of those. If you don't need them, don't use them. The next thing that we can do is there's a new feature that came out relatively recently. It is the declarative ETH calls. Essentially, we declare the ETH calls in the actual subgraph.yaml, in the manifest. And then from there, we actually store that data in a cache, and then it's more accessible as opposed to getting it from the chain every single time. We store it in the cache. So do we need to go into code on that one right there, or are we okay just talking about that?
It would be good if you go to the code and
okay.
Yeah.
Okay. So let's just say hypothetically, we are looking at this smart contract right here, and we're saying, come on, there we go. And we say, in this smart contract, we have a few different, we're in the subgraph.yaml right here. And we are getting these events from the chain. We're getting the handle claimable amount set, and we're getting the handle ownership transferred, and we're getting handle tokens claimed. And we're like, those are all events. That's great. However, we need to actually call some smart contract data through the functions. They're not emitting events. We actually need to call it through the view function of the smart contract. So let's go to the smart contract and say, here we are. Here are the smart contracts. Let's go find a function in this smart contract. Here's the read contract. So we're reading, these are view functions, and we can see we want to get balance. And this is a call. This is a function where we could get the balance. And let's go latest query. Okay, what is it? There we go. We're not getting that in there. So let's get what's the block number that we want to pass into this? Let's see what a recent block is on Metis. Where's I want to go here. Why are you like this? There we go. Transactions. And let's see what a recent block is. Okay, let's just grab that one right there. Come on, copy. And from there, we go to here and query. Okay, 0. That's fine. Okay, we're still making a successful call. And I don't know how the smart contract works, but whatever. We're getting this right here. So we want get balance, and we need to be able to do that. So let's go ahead and go into here. We should name that actual call that we're going to do, and we name that here in the subgraph.yaml. If we have to do this, once again, this is not the best practice to use these. Ideally, we don't use them at all. We get all our data from the smart contract itself. But if we have to, because maybe we don't own that smart contract, we should do this. Is this all making sense so far?
Yeah.
Okay. If I have to review anything, let me know.
Yep.
Okay. So essentially, they can only be declared for event handlers in the manifest. So anytime this event happens right here, the handler fires, and then the call, we're able to actually get that and bring that in. It's a little interesting way. So we simply drop it in, and we go event handlers, and then we go into the handler and we say call, and then we're not going to do claim tokens. It is the calls ERC20 pool info, ERC20, and then it goes pool info, and then from there we can drop it in. So yeah, get pool info. And we don't want pool info because that's going to be the what's the actual name of the dang thing? Where was I? It was here. Get balance. That was it. Okay, so then from there, we continue to extend that out. We have all that information, we're basically declaring exactly how we're going to go. I'm not going to go through all that real quick, but the next thing we have to do is actually handle that information with the tokens claimed. So we're in the tokens claimed. We're going to go to the handlers, and we'll go tokens claimed. Here it is. And this is the handler where essentially we're saying, hey, the event is coming in from the chain. This is the event coming in from the chain. This triggers anytime the subgraph sees this event. And then from there, the processing begins, and we pass all that information from the chain into the database, and we save the entity in the database. And then from here, we would be able to go ahead and, where is it? As you could tell, I'm not using ETH calls all the time. That's not something I do all the time. But essentially, we go ahead and call it using the same way that we were doing it before. So first we have to bind it here. So we'll do a let instance equals ERC20 bind address, and we have to actually import ERC20 as a little library. So import, there it is. And so we have to generate it also. There's all these little tiny things, but once again, that's not correct, but I'm not gonna, no, that would be correct. And then now that we've bound it, we're able to go ahead and there we go. Oh, nice job, tab. Nice, okay. Well, we won't talk about that. That's a little bit more advanced. We're not gonna do if returns. We're not gonna do that. And so from there, yeah. So, oh, good. It has a try automatically in there. I like that. Try basically is making sure it's not going to break stop the subgraph from indexing. If you simply just did balance of, it would, if the function failed, it would essentially stop the subgraph running. But this will allow error handling to be elegantly handled. So that's nice. So does that make sense?
Yep. Till now,
yep. For the most part.
For the most part, yeah.
we're getting a little advanced here.
Yeah.
But just to avoid this, pro tip, don't use ETH calls. Because ideally, you don't need them. So that's the bonus extra hot tip for the day. So don't use ETH calls. This is a way that we have them if you need them. Okay. So the last one I'll do here, I'm not going to do grafting and Hux fixing. This I love. I love this one. Shout out to the graph node engineers who built this. You know who you are. Time series and aggregations. So let's say you want to get first, last, top, bottom, basically like do math with time series with your subgraph data. Let's say you're getting in all of these different entities in here, but it's just simply raw data that's coming in. Like we said, logs of the data. Wouldn't it be nice to not just store raw logs of the data, not just do relationships with the data, but to truly do computations with the data? And that's what time series and aggregations can do. It's really nice. Where are we going to go here? I'm not going to build this out. Where is it? Time series and aggregation entity. There we go. So just at its root, we can do sum, count, min, max, first, last. This is really nice within subgraph creation. If you're getting a lot of data coming into any one of your entities, before it fully gets saved into your entity, you can go ahead and build it out. Essentially, what you have to do is build out a time series entity and a aggregation entity. Essentially, a time series is exactly that. It's time here, time there, time there, time there, typically like hour or day, every hour, every day. That's a time series. And so we define it right here, and it's a time series entity where there's a lot. Read about this. That's all it's really, get some information in here. And it's from here, we have an aggregation entity, and we essentially are taking the data and we're doing the computation in this location. So we're seeing a sum, last, a count. We're actually doing that. This is really all the code you need to do this. So it's not like super, you don't have to go in and do, like actual, math using the assembly script. This is all done for you, and it's really good for snapshots. Highly recommended you get familiar with this. If just the first, last, all of this is not enough, don't you worry, because there is, where is this right here? Where's the GitHub repo? Read. Here we go. This is the README. This goes into, this is where it gets super powerful, the SQL functions. So you can do much more than just first, last, and max, min, this type of stuff. There are many type of operators, greater than, less than, all of these. I mean, once we're getting into SQL functions, we're doing a lot. Power, sign, coalesce, nullif. I mean, there's a lot you can do with mathematics with this if you want to do that computation in the subgraph itself. And that is a super power user move for any builders out there that want their subgraph to just, as soon as you send the query, you're getting that data back and you don't have to worry about it on any other layer. This is really nice. So shout out to the Graph Node team who built this out. This is one of my favorite features they've released in a while now, and that's very impressive. So this is a little deeper. This is probably the most advanced that we're going today with time series and aggregations. I think that is reasonable for today's workshop, because I want to leave 5-10 minutes for questions. If anyone's interested in this, I'm not going to build this out now, just to say this, but please read this one. This is in the end, this is generally all the code that you need if you need the most basic version of the code. So that's everything for what I'd like to share today. Do you have any questions? Does anyone out there have any questions?
I don't see any question yet in the chat section. Guys, feel free to drop the questions and let's take the advantage that
For sure.
Regarding the subgraph. So we were happy to have the more questions on the chat section.
And if there's no questions, that's okay too. I'm happy
Yeah.
to vibe and hang out. The overall, subgraphs are super powerful. And if you are looking to build a subgraph, feel free to reach out to me if you have any questions. Discord is actually very helpful too. Discord community, shout out to the Graph Discord. The goal is very much to learn this style of development where essentially getting data from chain can be quite customizable. There's a lot of different ways to do it. It can be very simple. We do have token API for that, and we're extending that a lot for simplistic use, just to send a REST query over and just get that data. And if you want more customizability, highly recommend that you check out subgraphs. If you want another option, we have substreams, but that's a whole nother workshop,
Yeah.
which we do not have time to go into in 10 minutes.
Yeah. For the next time, maybe.
Maybe the next time. So yeah, let me see if there's been a response. I'm not sharing my screen on the new chain.
Yeah, but I mean, I don't see what is the question right now, but yeah, let us know if you have got the update for the Hyperion testnet,
Sure.
because I'm pretty sure that people or the devs that are in the hackathon, that are the part of the hackathon, they might be using Subgraph for their application. So that would be great if we can integrate the Hyperion testnet, especially for as early as possible. Yep.
Yep. I've reached out to the chain integrations team, and I will send you a message as soon as I hear anything with the chain integration. Yeah. And so, Nidhi, I'm really happy I was able to pass through and help out the baby subgraph builders out there. And so, and I feel like if anybody is able to build a subgraph and get going well, I think it's you right now. So, and so that's really a cool thing. I'm happy to share with you and happy to share with your community. That's really nice. So, if also if there's any other support that you guys need with the graph, I know we're extending some new features and we're pushing on some new features internally. We can't wait to announce those in the coming X amount of months. So be happy to hop on with you another time and share what we're building when the time is right.
Yep. So, all right. If there's no question in the chat section, I think we can wrap up the session. And before we wrap up and end up the session, I would like to mention one more time that in the Metis community, there is one global hackathon, Hyperion hack is going on, guys. So as a developer, and if you're into the AI and Web3 space, this is the chance to get into the hackathon, and there's a prize money which is like 200k USD in total. And if you integrate Alith, then you'll get like on the top of this your total price. There is 30k more for the just the Alith integration. So make sure that you participate in this and you use Subgraph somewhere at your project, and let us know if you need any support, or if you have any query, questions, feedback for while doing the hackathon, while integrating your things with the subgraph into your project. Let us know. We are here to support you all the time, and happy to be here in this special workshop where we learn about the special techniques with the graph with the help of Marcus Devrel from the graph. All right, so time to wrap up. Thanks all for being here. Special thanks to you, Marcus, for joining us today and giving us a lot more information on the
Yeah.
techniques.
Yes,
Yeah,
there's more too. So it's like
yeah,
this is data and data transformations,
yeah,
and I think I'm excited that this is out there for your development community, and use those best practices. If you just use those, you're ahead of the game, developers
yeah.
for sure. Yep.
Hoping to see you soon for the next workshop with the most advanced techniques of the graph.
Yeah, the next
Yeah,
technique is you just think the data and it just
yeah.
appears in front of you. Yeah, that's a new feature
That's a new
that we're
feature.
working
Yeah.
on.
Cool, amazing.
Well, thank you
All
so
right.
much for having me, Nidhi.
Yeah. All right. Thank you. Bye, guys. Take
Bye
care.
bye.
All right.